I get this wrong, Eric Hajduk?
Yeah.
And he's with Universal Power Solutions, Inc., and he's a general manager. He's going to talk about issues for downhole high power systems, so very topical here. Eric is a mechanical engineer from the University of Calgary. He's been involved in medical research for 10 years, after which he co-founded a medical device company. Now he's involved with battery systems for the oil industry. Thank you, Eric.
Forward, reverse, and laser.
Okay, so forward. Okay. Okay. Okay, I'm going to briefly tell you what we do at Universal Power, why we do it, and some of the issues we have. So we provide the energy for some of the applications we've talked about. And our main business is providing the battery packs that are used in downhole drilling. And I'm not sure you know about downhole drilling, but in the directional business, they need the power to power the sensors that monitor the inclination, angle, the gamma, and which that gets sent to the surface. The tools that we power basically reside around 50 feet behind the drill bit, so they're subjected to lots of shock, vibration, and of course, as you heard, the deeper you go, the higher the temperature. And the battery packs are standardly built with lithium thionyl chloride cells, which we don't make. We work with some partners who manufacture the cells, and we package them together in a proper packaging with the connectors that are appropriate for the conditions that they're going to see. These battery packs are not rechargeable. They're primary lithium cells, so they get sent out, they get used, and disposed of. Typical usage would be 100 hours to 500 hours per battery pack. The problem with the industry is that the operators who use these cells have to manually keep track of how they're used. And not many of our customers are that organized. Literally, it comes down to labeling a marker on the side how many hours they're used. One job, they might be used 30 hours. The next job might be used 70 hours. And eventually, they have a threshold where they feel comfortable using them, and they dispose of them. And like I was saying, sometimes they could be used 100 hours on a job, but these tools that they're powering are very modular. Sometimes you would use it with 3 sections or different sensors, a gamma module, a resistivity module, and it's all cumulative how much energy is being drawn from the batteries. And the whole nature of the downhole drilling industry is that failures are not acceptable. If there is a failure, the whole rig has to shut down. They got to pull up, 5,000 feet of pipe, switch the part, and away you go again. If you're lucky, if you have a problem, it coincides with the bit being required to be changed, and it's not a problem. But if there is a problem, heads roll usually, and so given that, if there's a problem, our customers have to learn from what caused their problem. The directional business is being more mature now, but 10 years ago when it was starting out, problems were more accepted, and these days failures are less so. And if you do have a failure, you got to learn from it, have a proper CAPA, correct the problem, and make sure it doesn't happen again. So at Universal, we traditionally started making a standard battery pack like everybody else does, which is just a battery pack. But we've started specializing in is adding electronics to the battery pack. So in the space that's available to us, which is usually not very much, but these battery packs are standardized for certain tools. And we can't really ask the customers to give us a little bit more room. So we have to fit into generally a 1 inch by 1 inch area if we're lucky. And what we do is we put a little microprocessor board in there that actively logs parameters that battery pack has seen. So we measure and analyze temperature, current, voltage, how much energy has been removed from that battery pack. Hence, we can give the customers an estimation of how much energy is remaining. The way these battery packs work is we know how much energy should be in the battery pack. When they're brand new, there's so much lithium in there, and at a certain temperature, a certain current draw, so much energy could be withdrawn from that pack. It comes down to a chemistry experiment. So we know how much energy we got taken out of that pack. We can tell our customers how much is remaining in that pack.